okay? And I'm going to go over exactly why in this lesson. Okay, so in this lesson, there's a lot of review of what we did yesterday. So if you were here yesterday and you understood that, you'll probably be in good shape with that. But right off the bat, it looks like we've given a new formula, and it's actually not. This is just Pythagorean theorem with one of the steps already done for you, right? You know that you're going to have to take the square root of something. So here's the thing. When is this a nice and easy formula to use? Well, anytime you have the x and the y, because you just can plug right in here and take the square root. It's just Pythagorean theorem, okay? And I'll show you. There's not even any in our notes to do, but the homework, there's some in the homework problem. I'll come back to when this is useful, but really it's just Pythagorean theorem. Don't stress about it. It's just one step easier because it does one of the steps ahead of time for you, okay? Also, something we always do in algebra is work with equations, right? How many equations do we work with? We have like slope-intercept form, point-slope form, all different things. For example, you're given an equation that's just in some form, and you're told to put it in slope-intercept form. So you have to rearrange an equation, move things to one side or the other. There's reasons for that all the time, and we're going to do that right here for a reason that I'll get to. So let's just focus in on this picture on the quadrant 1 triangle. Ignore all the other stuff. So just like we learned yesterday, we always make a right angle with the x-axis. Theta is always at the origin, just like we did yesterday. Okay, so look at that. And this is your x, this is y, right? That's how you would get to that point. This side is x, this side is y, and they're calling this radius. We've called it a hypotenuse, we've called it c. Remember, a name is just a name. So, what I'm getting at here, eventually, sine, when we do SOHCAHTOA, is opposite over hypotenuse, right? So if I replace op over hype with letters from this picture, that would be y, right? Opposite is y, r is the hypotenuse. That just happens to be the letters we're using. What I'm going to do is take sine of theta equals y over r, and I'm going to rearrange the equation with one step and solve for y. Remember, when I solve for y, that means isolate the y, get the y by itself using inverse operations. This is y divided by r, so I'm simply going to multiply both sides by r. That'll cancel, and we get y equals r times sine theta. That's going to be really important in a minute. We'll come back to y. Let's do the same thing for cosine. Cosine is adjacent over hypotenuse. So in this picture, adjacent over hypotenuse. Remember SOHCAHTOA, A over H. So in this picture, adjacent is x, hypotenuse is r. So what I have is cosine of theta equals x over r. Let's solve for x this time. Same math. Multiply both sides by r. And we get x equals r cosine theta. We now have two new formulas. Why do we have these? Well, sometimes we're trying to find sine and cosine, or we're trying to find different things. These formulas are taking sine and cosine facts, the formulas form, and rearranging the equation. So you're going to be given a radius and a theta, and you plug into these formulas, and that gets you the ordered pair where that happens. So let me make that connection. What we have here is we have an angle measure, theta. That's what that means. There's an angle measure of 4 pi over 3. And a circle with a radius of 5, centered at the origin. What we're trying to do is find the coordinates of that point. Okay, so let me explain what this is saying. 4 pi over 3 should sound familiar to you. It's one of your unit circle angles, right? It's in quadrant 3, right? 4 pi over 3. So let's start by drawing the triangle in quadrant 3. So it's already started for us. Remember, right angle with the x-axis, theta over here. Now, what I just told you, what I've been hammering into your brain this week is that when we are talking about the unit circle, it's a radius of what? 1. Radii are all 1. That's why it's called the unit circle. Unit means 1. Now we're changing the radius to 5. That's going to change the ordered pair. Because if we were talking about a radius of 1, that's what you just wrote on that paper. We already know the ordered pair when the radius is 1. Let's come up with that. When the radius is 1, this angle sits at this point. So denominator of 3, this is exactly what your trig quiz is like. Denominator of 3 means we start with 1/2, right? You get your ordered pair from your denominator. Numerator tells me I'm in quadrant 3. In quadrant 3, I go left, down. These are both negative. So if I asked you, what's the ordered pair, the x and y, if radius are 1, you'd say that. But when we change the radius, think about it. We're just multiplying the cosine and sine value by the radius, and that gives us our new ordered pair. It just kind of extends it, okay? So we're going to use our 2 new formulas. Okay, so radius was given, and theta was given. Right, do them at the same time here. And cosine of 4 pi over 3 is negative 1/2. So I'm going to do 5 times negative 1/2. When I multiply fractions, I don't need a common denominator, right? That's a 1. So x would be negative 5/2. That would be the x value at that point. Radius given to us. Okay? What? Oh, okay. Good now? Sorry, go ahead, stop. I'll stop. So radius was given to me as 5, right? And then cosine of theta. Theta was given to me as 4 pi over 3. So I replaced theta with 4 pi over 3. Cosine of 4 pi over 3, remember, cosine is x. So that's, I just plugged in negative 1/2 for all of that, and then multiply. Same thing over here, same radius. Sine of 4 pi over 3 is negative square root of 3 over 2. Okay? Multiply that. Don't overthink it, guys. 5 and a negative 1 basically is just negative 5. Square root of 3 is on the inside, and 1 times 2 is 2. Yeah. This is the ordered pair, or xy, at that point. Okay? You can't do this problem if you don't know the unit circle. I just used my unit circle knowledge, and you all nodded along with me. No one's like, where the heck did she get those? You know those. That's why I'm telling you, you have to know the unit circle. If you're sitting there like, I would never have known that, that's because you don't know the unit circle. That's what I mean about having to have that imprinted in your brain. You're going to have problems like this without a calculator, without the unit circle in front of you ever, and you have to know this fact to be able to do the problem. Otherwise, you can't do the problem, right? Okay? So that's why we're doing this. Don't put yourself in a situation where you're just giving up on this, because you're going to be miserable. Okay? You're going to be miserable. All right. If theta this is just like the ones we were doing yesterday. If theta terminates in quadrant 2. So that's just telling us we have a quadrant 2 angle, triangle. Let's draw our quadrant 2. So sometimes they're really nice and they tell us what quadrant it's in. We don't have to guess. Or not guess, but figure it out by other stuff. And what's given, they're giving us this. That was given to us. And they're asking for what is sine. Okay? So let's first talk about when you have a fraction that's negative, there's really 3 ways you can write it. You can put the negative right in the middle. You could put it on the top. You could technically put it on the bottom. And the whole point I'm making is that we know cosine is adjacent over hypotenuse. So here's my adjacent side. Here's my hypotenuse. There's one negative. We have to decide, does it go to the numerator or does it go to the denominator? Well, it should make sense when you go look at your graph. If I start here, this is my adjacent side, I'm going to the left. We respect the coordinate plane and remember that when we go to the left, it's negative. And hypotenuses are always positive. So that takes care of who gets the negative. It should be obvious if you understand the coordinate plane sign. Okay, if I need sine, that's opposite over hypotenuse. I need my opposite side. This is my opposite side. So I'm going to use my good old handy Pythagorean theorem. Show as much or as little work as you want. We did so many of them yesterday. A squared oops, plus b squared equals c squared. That's 1. Square root of 8. Now let's talk about the square root of 8. It is a very popular radical. It's going to come up again and again. It can be simplified. It's not a perfect square, but it has a factor that's a perfect square. So 4 goes into 8. And so to simplify this, it would be 2 square roots of 2. I would just memorize it. You're going to see it all the time. Square root of 8 simplifies to 2 square roots of 2. So b is plus or minus 2 square roots of 2. So that's my opposite side. We have to also decide, that's my opposite side. We have to decide if we're going to use the positive or the negative. Positive. How did you know, Michelle? We're just going up. So positive 2 square roots of 2, right? If we were going down, we'd do the negative. Ready to write our answer? Sign is opposite over hypotenuse. There it is. Okay, so those are just like what we did yesterday. Right? A lot of mistakes on this one today as I was going over it. I was kind of asking. So what this is asking, okay, and I don't really like the way it's worded, what thetas that are between 0 and 2 pi? Anybody have an idea what they think that means? What are we saying when I say that? What does 0 to 2 pi make you think of? What's that called? The unit circle, right? Yeah. What we're asking is, what thetas between 0 and 2 pi, so code for on the unit circle, have a cosine of 0. Cosine is x. So I want to know, where does this happen? What thetas do I have? Go find it. Don't say it out loud yet. Think about it. I want to give you guys a chance to find it. It's been a lot of mistakes today from students, and it worries me. Because then I grade their unit circles and they're right. But think about the unit circle. Where do I have x's that are 0? Michelle, where? She says top and bottom. Anybody want to disagree? Good. I wouldn't. Okay. Good job. So what I'm saying is, and everyone has been saying this, guys, there are zeros in all of our quadrantals. Remember, that's why I said people get those confused all the time. Where is cosine 0? Up, down. Remember when you're teaching mom how to graph those 4 points? You would never get those wrong. Don't get them wrong when they're in a problem. Don't choke. You know where x is 0. It's here and here. And we usually answer our questions in radians. So the answer, pi over 2, 3 pi over 2. That's it, okay? The reason you're given this, and this is the first time you're going to see this, and you're going to start seeing it all the time, is because if we left that off, and I just said find all the values where cosine is 0, guess what? We would spend the rest of our life writing these, because you could add 2 pi forever, keep adding 2 pi, or subtracting 2 pi, and you'd get coterminal angles at the top and the bottom, and those all have cosines of 0. And we could do this for the rest of our lives and never finish the list. So they're restricting us to just in that little unit circle that we know, give us the 2 that have that, okay? Next one, another situation where you're given some clues to figure out where our triangle is. Sometimes they're really nice, they just tell us. Sometimes we're given an ordered pair and we travel there and that tells us where it is. In this case, this is the first problem you're seeing where, as for the y of why I taught you that. Remember, we talked about all students take calculus. That's where your trig functions are positive. I'd give it to you for the unit circle, but I don't think many of you use that for the unit circle. I think it's easier to just try to think of left, right, up, and down. But there is a reason I taught that to you, and it's going to come up. You'll see it a lot, where what I'm trying to figure out first is where do I draw my triangle, and then we're going to find sine and cosine from that, just like we have them, okay? Now, I have a tan of theta is 4 over 3. What that means is tan is positive. See it? It's positive. It's a positive number. Tan is positive. And this is code for cosine being what? What does that make you think? Is cosine positive or negative if it's less than 0? Negative. So what we do is we use our little all students take calculus trick, and we narrow down to which quadrant, there's only going to be one, where tan is positive and cosine is negative. So first of all, tan is positive here and here. So I'm immediately getting rid of those two, right? All means all are positive. T means tan is positive, okay? Now I'll use my second clue to decide which one of these is where cosine is negative. Third, right? Cosine's positive. Now I know my triangle is going to be in quadrant 3. So it's all about looking at the sign of whatever is given to you. They'll give you another little hint. They will give you enough information to narrow it down, okay? So we have a quadrant 3 angle. And guys, understand, they just gave us the angle measure. That's what they gave us. That's not like an opposite or adjacent or an anything, right? That is literally just the angle. So what we want to find is sine of theta and cosine of theta. That's what we're trying to find using that. Well, no, I just said the wrong thing. Am I thinking of a different one? I'm thinking of a different problem. I am so sorry. Ignore what I just said. It does say tan is, sorry. I'm so sorry. I knew I was losing my place with that for a second. That's why I just opened my notes. Okay, everything's fine. So remember, they gave us this. This is opposite over adjacent. I was thinking of one that we had where it was just the angle. I don't see it right now. I forgot. So anyway, opposite over adjacent. So here's our triangle. Opposite would be over here. Adjacent would be here. But remember, I told you this yesterday. Anytime we're in quadrant 3, we have to be on our toes. Because even though tan is positive in here, each of these individually are negative. It just gets simplified to a positive when you do a negative over a negative. Respect the coordinate plane. I'm going left and down. Negative, negative. Yeah, because if you go to the left, Peter, you have to make that number negative. If you go down, you have to make it negative. Why wasn't it negative, negative here? Because it's been simplified. Negative over negative is positive. Okay, now, we also talked about this yesterday. If you remember 3, 4, what triangle? 5, then you don't need to do Pythagorean theorem. If you didn't remember that this is a 3, 4, 5 triangle, you would do Pythagorean theorem and find your hypotenuse. But I don't care about, I don't ever need to see your work for Pythagorean theorem. So if you know it, or you can do some of it in your head, go right ahead. All right, sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. Done. All right, last one. A machine shop needs to drill through a steel plate at point P. Calculate the actual measurement for the placement of the hole, then use your calculator to approximate the location. Okay, bottom line is this. Look at it. They gave us an R. They gave us a theta. They want an X and Y. This is why we learned these two new formulas. And they're easy to remember because X goes with cosine, Y goes with sine, right? And again, radius is given, is 14, times cosine of my theta is 25 degrees. Let's go ahead and plug this one in. Radius is 14 times sine of theta, given also 25 degrees. And the first one we did, the one we did a few minutes ago, it was on the unit circle. It was one of our unit circle angles. This is the one I was trying to remember about. That's 4 pi over 3. So we knew the ordered pair for that. We don't know what cosine and sine of 25 degrees is. It's on the unit circle, but it's not a standard angle, just below 30, right? So this is why they're saying use your calculator. We're going to actually use our calculator to do this. So it's just typing some buttons and rounding. But one thing you need to know is that if you clear your RAM, so do me a favor and clear your RAM. I might have talked about this before. I might not have. I don't know. But your calculators, when you clear your RAM, so in its cleanest basic state, your calculators are naturally in radian mode. So anytime you have to calculate degrees, you literally have to go to the word mode, go to mode, and if you look down, see how radians is highlighted, like 4 down, arrow down to it, arrow over to degrees, and hit enter. So degrees should be flashing or highlighted. Your calculator is now in degree mode. If you don't do that, your answer will be wrong, okay? So now we just type it in. 14, and cosine's right here in the middle, cosine 25 and 14 sine 25. And there's my x, there's my y, rounding to 3. Oh, thank you. 14, thank you, times cosine of 25 and 14 times sine of 25. Fine, be picky. Okay, those are my two ordered pairs. Okay. Makes sense that they're both positive. We're in quadrant 1. 12.688, 5.917. So why are we getting decimal answers? Well, first of all, we had to go to our calculator. And in a real world problem, you're not drilling at 4 square roots of 3 over 2 or something weird, right? You need exact measurements. So if you're a carpenter or an engineer or an architect or something, you would need exact numbers of where to make that drill hole. Okay? All right. Yeah, I will. What I'll do is just check on anybody, see if you guys need any help. I'm going to do number 3 with you, then I'll let you guys work. If nobody needs my help, I'll start grading. But helping you comes first always, of course. Well, I don't know if I should say. I had it ready. I had it already. I gave the ultimatum. Either put your phone up. You get it. This phone up. Anyway, he put his phone up. Okay, so number 3 is just like yesterday, okay? Given an ordered pair, find sine and cosine. So we're going to first draw our triangle in the correct quadrant. So when it's an ordered pair, we just travel there. Left 8, up 5 puts us in quadrant 2. Yep. So triangle, right angle with the x-axis. Theta is always at the origin. I went left 8, up 5 to get there. I need my hypotenuse. So here's where I told you that new quote-unquote formula can come from. I need my radius, so I can just square each of these and add them together. It's just a little quicker, okay? We're still doing Pythagorean theorem. This formula is nice when you have x and y. You just plug it right into there. R would be plus or minus the square root of 89. This is a hypotenuse, and it's always going to be positive. Done. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And as we learned yesterday, you're welcome to leave the radicals in your denominator. We went over how to get them out of there in case you had a multiple choice question like that, but you are allowed to leave your radical in the denominator. Okay? I did 3 with you. Remember, we have a work day on Wednesday. Even if you're taking both quizzes, that's only 7 minutes of your time, so don't stress if you don't get your homework done. Hi. Say it again. Oh, okay. Did your class start already? Oh, no. Who's your teacher? I'm not supposed to write past it. Yeah, Josh. Yeah. then you're going to come back after school.